Okay, so I've given you this huge philosophical lecture about why log scales are cool, why log graphs are cool, why you would want to use them. But I want to give you a tutorial now on how, if you're presented with a set of data points, how can you fit an exponential function to it if you want to. And so first we want to say, you probably know this, but we want to model things. We want to fit equations to our data sets because we want to do cool things like make predictions about things that we haven't measured yet. We want to see patterns that maybe we couldn't see before. So fitting functions to data sets is a very important skill. And so if you accept that you're wanting to fit a function to data sets, well, you need to figure out or you need to make guesses about what the relationship between your two variables are so that you can proceed with various accepted methods of fitting functions to things. Some relationships are linear, some of them are quadratic, and some of them are exponential or logarithmic. We want to be able to fit exponential functions to data sets if we think the relationship might be exponential. This is pretty hard to do, but fitting lines is actually much easier to do. In fact, a lot of times we make people do it just using Excel. If you have a bunch of XY pairs, you can use Excel functions to fit lines to them. So, if you have a data set and you're looking at it, you plotted it and you're looking at it and you think, by gosh, I think this relationship is exponential. Here's what you do. You take a logarithm of the y-coordinate of every point that you've got and you do another plot. And now, if it looks linear, your guess was probably right. It was probably an exponential relationship. Here's the GDP graph that I was working with in the last video. And if I'm looking at this, I see that the behavior is shallow, 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 steep, 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 steep. So I'm thinking exponential. So I'm going to take all the points that I had and I'm going to apply a logarithm to them, right? And so this is the plot that I get. And absolutely, this guy looks really linear now. So I get really excited. My guess was probably right. The relationship is probably exponential, and I should probably proceed with trying to fit a function to it. So, okay, here's a data set that I just made up in Excel. Let's suppose we have a data set that looks like this. And I can tell that it's kind of like curvy. So I'm thinking not linear. I think not linear. But actually, this one looks kind of fuzzy enough that I'm like, I can't tell if it's supposed to be like an exponential model or a parabola model. Maybe it should be y equals x squared or something, right? I think it's kind of hard to tell here. So I'm going to do this test. I'm going to take every single data point that I have here, and I'm going to apply log base 10 to it. And so this is what I get instead. And I'm thinking, party, 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 this is definitely exponential. Well, this guy is linear, therefore this guy is exponential. So, okay, I've done my test. What am I supposed to do to actually fit a model? Well, you need to take this is a log linearized data set, right? And you need to fit a line to this data set. Now I'm going to do it quick and dirty. I just grabbed my line making tool and I just drew something that looked convincing. But obviously you have more sophisticated methods of fitting a line to your data set if you want to. So now once I've drawn the line that I think looks pretty good, I'm going to find out the equation for that line. And as you know, 2 points determine a line. So I measure 2 points on this line that I drew, and I actually make an equation for a line based on that. And I'm going to simplify this so that I can move forward. So this is my linear model for my log linearized data set. Okay, now, I hope I can say this clearly enough. Me writing y here is a little bit of a lie. Notice how this is my x-axis, and this graph is log y, right? I applied log to everything. So this axis is actually log y. So really, if I'm being honest with myself, the y coordinates for this graph correspond to log y. And so my model is log y equals 0.5x plus 1.2. And so this is how I'm going to get my exponential model for my real data set by exponentiating both sides, and I get 10 to the 0.5x plus 1.2. Now I've noticed that in many books and websites, people don't seem to like this. I really don't give a rip, but more commonly I see people using the properties of exponents to rewrite this as 10 to the 0.5x times 10 to the 1.2. And I got out a calculator to figure out that 10 to the 1.2 power is 15.8. So This is my exponential model for my original data set, which I've brought back right here. I want to plot it. I'm going to sketch it real quick by hand and see just how amazing my model is. So I got out a calculator and I made some points. I plotted 0, 1, 2, and 2.2. I tried 3 and 2.5, but they were too high. So I've got some XY pairs that I can plot. And sure enough, it makes the most gorgeous exponential curve that appears to fit my data set ever. So party, 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 I just modeled an exponential data set.